Hey there, welcome back to Common Core Algebra II. Today's lesson is 5.5 Geometric Series. And just like we did in 5.4, this is just an expansion of that because we're not talking about arithmetic series like we did yesterday. We're talking about geometric series, which is basically, if you're talking about a geometric sequence, it's just the sum of that sequence. And there's two formulas you basically need to know. The first formula, and both of them, by the way, can be found on your reference sheet, which is a beautiful thing. But the first formula is to find the nth term, all right, which is usually the last term. So to find the nth term, it's a sub n is equal to a sub 1, the first term, times the common ratio raised to the n minus 1. And to find the sum, that's going to be s of n, so the sum of the first n terms is equal to the first term times 1 minus r to the n, all divided by 1 minus r. So you might want to write those down because you'll be using them a lot during this lesson. All right, so let's just get into it with example or exercise number 1. So given a geometric series, make sure you're realizing that you are underlining these things. So a geometric series, so you know what formulas to use, is defined by a recursive formula. A sub 1 is 3, first term is 3, and in making sense of this, the term I'm looking for is equal to the previous term times 2. All right? So which of the following is the value of the first 3 terms? Now, we can easily do this because it's only 3 terms. So make sense of what the sequence looks like. So A1 is 3. So A1 is equal to 3. A2 is equal to the previous term times 2, which is 6. And A sub 3 is equal to the previous term times 2, which is 12. And here they're saying we need to, oh, no, I'm sorry, and then it's up to 5. So I need to find the next 2. So the previous term times 2, and A5 is the previous term times 2. And if we add those up, 3 plus 6 plus 12 plus 24 plus 48, we get 93. All right, so before you start looking at what the series looks like, you have to make sense of what the sequence looks like. Because the series is simply just adding all the terms of the sequence up. So the sum of a finite number of geometric sequence terms is less obvious than that for an arithmetic series, but can be found nonetheless. So the next exercise derives the formula for finding the sum. All right, so basically, this is the formula I just talked about, but this is how we kind of derive it. So it says write the expression, okay, I'm sorry, recall that a geometric sequence, the nth term, is given by this. Thus, the general form for a geometric series is given below, so which is given by this. So write an expression below for the product r and s of n. So that's simply going to look like, all right, so what do we end up with? We end up with r times this whole thing, a1 plus a1r. My goodness, this board is just going crazy. Plus dot, 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 a1 r to the n minus 1. All right, so then what does that look like? It looks like a1r plus a1r squared plus a1r cubed plus dot, 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 a1rn. Okay, so when you subtract them now, basically you end up with this whole thing, which was the a1 plus a1r plus a1r squared plus a1r to the n minus 1, and you subtract out the a1r plus a1r squared plus a1rn, and what you end up with is, because if you look here, these cancel, all right, and then this one would cancel with the one before it, and we'd simply be left with our first term plus a1r to the nth power. Write both sides of the equation in B in their factored form. So we have Sn minus r times Sn is equal to a1 plus a1 r to the n. So basically, if we take the Sn out of this, we get 1 minus r equals a1 times 1 plus r to the n. All right, and then on D, it says from the equation in part C, find a formula for S of n. So in other words, just divide both sides by 1 minus r, and we get Sn is equal to a sub 1 of 1 plus r to the n divided by 1 plus r.
Please come to the main lobby. Your ride is waiting for you.
Sorry for the interruption. All right. So that's where that formula comes from. You'll never be asked to derive it, but we want you to sometimes understand where things come from. So moving on to exercise 3. Now we get into some of the good stuff. So which of the following represents the sum of a geometric series with 8 terms whose first term is 3 and whose common ratio is 4? So we know that we're talking about a geometric series, has 8 terms, right? N is equal to 8. The first term is 3, and the common ratio is equal to 4. Do I need anything else here? If I think about what my formula is, and the answer is no, we have the first term. Do we have the last term? We do not have the last term. Do we need the last term? Nope, we don't. I was thinking about the arithmetic series, which means I need the last term. So use the formula. So the formula is Sn is equal to a sub 1, 1 minus r to the n, all over 1 minus r. So this is equal to 3 times 1 minus r, which is 4 to the 8th power. I'm sorry, this is S8, over 1 minus 4. Do the math. The whole thing goes right into your calculator, and you get 65,535. So my correct answer is number 4. So down here in the box is just a repeater of the formula that we've written down a couple of different times now. So again, I like using this particular one. I'm not a fan of this one here on the right, but if that works for you, that's fine too. But like I said, you don't have to know this. This is on your reference sheet. All right, but this is basically when we're talking about a geometric series, you're talking about those 2 formulas that we wrote down at the beginning. So in exercise number 4, we know that this is saying find the value of the geometric series shown below. Show the calculations that lead to your final answer. In other words, don't do the whole thing in your calculator because you won't get credit for the whole thing. So I know that a sub 1 is equal to 6, and I know that a sub n is equal to 768. All right, and the next thing I do is I write down the formula I need is equal to a1, 1 minus r to the n, all over 1 minus r. So what am I missing? Well, I can find my r, right, because I need my a sub 1, which I have. I need my n, which I don't have, and I need my r. And the r is basically what I'm multiplying to get to the next term. So I know my r has to be 2. So I need n. So I can't use this formula, so I have to use that other formula that I was using, which is a sub n. Again, it's right on your reference sheet, r to the n minus 1. So I know my a sub n, which is my last term, is 768, is equal to my first term, which is 6, times r, which we said was 2 to the n minus 1. All right, so there's 2 ways that we can do this now. You can use logarithms or you can use common bases. So you know me, I like to switch things around. 2n minus 1 is equal to 768. Divide both sides by 6. And 2 to the n minus 1 is equal to 128. Now, I know that 128 is the same thing as 2 to the 7th, so I can use common bases here. So I can say 2 to the n minus 1 is equal to 2 to the 7th, but you could very easily use logs. So I know that n minus 1 has to be 7, so n has to equal 8. Okay, Now, I'm going to kind of slide back up here, so if you need to pause, write this down before following me back up to the top. So now what I'm going to do is I'm going to take this, because they're asking me for the sum of the series. So I know that S8 is equal to a sub 1, which is 6, times 1 minus r to the 8th power over 1 minus r. And this, you put this whole thing into your calculator, and you get 1530 being your answer. Okay, so basically we're done. If you're an honor student and you want to sit and watch the next one, you're welcome to, but I actually don't think it's completely necessary. But I will continue on with exercises 5 and 6 if you'd like to do it. Regular Regent students, we're done, and we'll see you tomorrow, okay? As always, make good choices. You know I like to end my lessons with that because I always worry about you. So exercise 5. Maria places $500 at the beginning of each year into account that earns 5% interest. Remember, we're mathematicians, we don't deal in percents. Compounded annually. Maria would like to determine how much money is in her account after she has made her $500 deposit at the end of 10 years. So basically, what we're saying here is, now this says determine a formula for the amount A of t that a given $500 has grown to 2 years after it was placed into the account. Well, that's simple enough because that's what we've been doing all along. A of t is equal to my initial amount. We're increasing, so it's 1 plus 0.05 raised to the t. B says at the end of 10 years, which would be worth more, the $500 invested in the first year or the fourth year, and explain by showing how much each is worth at the beginning of the 11th year. Well, I know that A of t for the first one is going to be $500 times 1.05 raised to the 10th power, because it's got 10 years to sit in that account. And the second one is going to be $500 times 1.05 raised to the 7, because that's only been sitting in that account for 7 years. Now, I'm not going to do the math here, but obviously you can tell that the first one is going to be worth more because it's been sitting in the account gaining interest for an additional 3 years. All right, so now C says, based on B, write a geometric sum representing the amount of money in Maria's account after 10 years. So we're not going to actually calculate it, we're just going to kind of write it out. So we know the first $500 goes in. The second $500 is going to be multiplied by 1.05. The next one is going to be $500 times 1.05 to the second power. And if you keep going, it's going to be, after 10 years, 1.05 to the 10th power. So that's what it's going to look like. And the next one says evaluate the sum. So again, Sn is equal to a sub 1, 1 minus r to the 11th over 1 minus r, which is equal to my initial amount, 1 minus 1.05 raised to the, now it has to be the 11th year, all over 1 minus 1.05. Okay, because it's the end of the 10th year, so we have to do it to the 11th power. So you put this whole thing into your calculator, you get $7,103.39. Always remember, when you're dealing with money, round it to the nearest hundredth. Okay? And exercise 6. Love this one. A person places 1 penny in the piggy bank on the first day of the month, 2 pennies on the second day, and 4 pennies on the third, and so on. So this is that typical, you know, would you rather get paid $1 a day, or would you rather get a penny the first day and then double it every day? So this is that same kind of questions, but it's the first day of the month. So what is this going to look like? The first payment is 0.01, the second is 0.02, the third is 0.04, 0.08, and so on and so forth. All right? So I know here, and it says here, let's make sure we understand the question. Will this person be a millionaire at the end of a 31-day month? And show the calculations that lead to your answer. So I know that a sub 1 is equal to 0.01, it's a penny, right? R is equal to 2 because we're doubling it every day. Now, do we know what n is? Yes, they tell us at the end of a 31-day month. So n is equal to 31. So Sn is equal to a sub 1, 1 minus r to the n over 1 minus r, which is S31 is equal to 0.01 times 1 minus 2 to the 31st power over 1 minus 2. And you put this whole thing into your calculator and you get this beautiful number, 2147800. I put my comma in the wrong spot. So it's 1, 2, 3, comma, 1, 2, 3, comma. So it's 21,474,800. So make sure you answer the question, will this person be a millionaire? And you're going to say, yes. And here you're also going to take a minute and just say and explain and say, yes, he will be, because after 31 days, he'll have over $21 million. So this is definitely a payment plan that I'm going to talk to Poughkeepsie City School District about, because this is the payment plan I want to be on. So, and I'm even okay with this being years, not even just months. So we're done with the end of Unit 5. We're going to go over this in class tomorrow or the next time we meet, and then we're going to get ready for our review and our test. The review sheet has been made. It is available to you, and I will upload the solutions to the website at my earliest convenience, hopefully by the end of the day tomorrow. All right, so until then, make good choices again, and I'll see you next time.